Hello, everyone. Welcome to today's Dynamics 365 Tech Talk. Today's topic is priority-based batch scheduling. My name is Otto. I'm your technical moderator today. We're broadcasting today's session through Teams live events, and the audio can be heard through your device speakers. The session is going to be recorded today on behalf of the Microsoft Corporation. When you join this event, your name, email address, and or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to that experience. The recording itself will be available over on the Tech Talks Community Dynamics page within about 5 business days. If you happen to have any questions for our presenters or need support, feel free to go ahead and use that Q&A panel located on the right-hand side of the screen, and our presenters will be responding to your questions throughout the event. Thanks for your patience during these brief announcements. So presenting for us today from Microsoft, we've got Ajay Kumar Singh, Senior R&D Solutions Architect. And with that, Ajay, over to you.
Thanks, Otto. Hi, everyone. Good morning, good afternoon, good evening from wherever you are joining. Today's topic is priority-based batch scheduling, and I've been joined with my colleague Akshat Singh, Program Manager in the FastTech team, Harsh Birla, Senior R&D Solution Architect in the FastTech team. We have Mata Prasad, Senior Program Manager from the Dataverse team. Let's get started. So the agenda for today is the background. So we will be talking about the limitation of the current batch runtime framework. Then in overview, we will talk about what is priority-based batch scheduling, what are the advantages of having priority-based batch scheduling, how does it work, and then the prerequisites for the PBS or priority-based batch scheduling. We will also talking about the best practices and call to action. Okay. So background. So there are certain limitations that we have seen in the current batch runtime framework. So one of the key one is that the current there's a high content on the batch related tables that we have seen since AX 2012. So there is a 2 table, batch and batch job table, which is kind of maintaining the queue for my batches, right? So the batch in waiting, executing, and finishing. So we have seen and high contention, blocking, and the deadlock on those tables. So we had a feature introduced in PU 21, the batch contention reduction feature, which has kind of alleviated that contention. The number has significantly went down after that feature. However, we still see there is a high contention on the batch related tables. The other thing that we have seen as a limitation in the current runtime is that there is no way for me to prioritize a batch job. So example, I have set up batch jobs and I want to make sure that one batch job should be getting highest resource allocated at the time when it executes. There's no way for us right now in the current framework to do that. The way we have been doing it is by adjusting my batch groups and dedicating certain number of batch server or threads. The disadvantage of doing that is that my batch servers are not evenly utilized. So if you just look at as an admin over 24 hours, how your batch server is being utilized, how many threads that you have been using. And since I have certain priority jobs, which is going to run at certain time in a day, and if I do a dedicated allocation of certain resources to a batch group, my batch server is going to sit idle the rest of the time when it's not executing anything. So if you just look at 24/7, what it gives us is that we are not evenly utilizing or we're not better utilizing the underlying infrastructure that we got. The other thing that we see is there is no way to do the reserve capacity. So today, if I want to reserve certain number of threads for my highest priority batch, there's no way to do that. The way we have been doing is that create a batch group, assign to a batch server, and keep it only for the priority batch that they wanted to. And again, that will lead to a kind of a server not being utilized the rest of the time. And the other thing that we see is that the current framework that we have, the batch groups are tightly integrated with the batch server. So at any point of time, if we decide to add more nodes to your batch server or remove it because of any reasons, We can't do it from the backend, but what it leads to is that we need to send a notification to customer and partner that, hey, we have added a new node looking at your workload, and you need to start using that. And you can start using that by adding or changing your current batch group configuration to start using the batch server. Right, so there is a communication that needs to happen in terms of sending out the notification to the customer and master, the customer and partner. The other thing that we have is near zero downtime. So I don't know if you guys are all aware that we have a concept of near zero downtime. So basically, what we do is that for the Windows OS patching, which we do every third week of every month, right? And we ask for the customer and partner to provide a downtime for us to do that patching. This can be done in the near zero downtime fashion, which means that there will be a blip or in a very brief period of interruption, and then we can patch it. So we don't need a dedicated downtime that we have been asking today. And this cannot be done today looking at the current infrastructure, because our batch groups are tied with our batch server. So at any point of time, if I take one batch server off from my batch group, then any batch group that is assigned to that batch server is not going to execute. It's going to either error or it's going to wait until the batch server is back. So these are the kind of limitations that we have with the current batch framework. Now, what is PBS? So in platform update 31, we introduced the concept of priority-based batch scheduling. So basically what it does is that it decouples your servers from the batch group. So basically, once you turn on the PBS, you no longer need to assign your batch group to batch server. So it's kind of your batch, the PBS allow you to define the priority at the batch group, and the PBS platform itself for the framework will use the batch group that you have assigned to your batch priority that you have assigned to the batch group to execute on the available the pool of resources. So you are no longer assigning a batch group to a server. Based on the priority, in the PBS engine will pick up the batch job from the corresponding group, look at the priority, and execute from the available resources. Uh, the other thing is that now we talked about that with PBS, priority-based batch scheduling, I'm going to set up priority at the batch group level. However, if you want to override that at a particular batch job level, that is also doable. So example, you have a you have a batch group, you set the priority at a priority X or low or high or critical, which we'll be talking about later. So you set a priority and you have 10 batch jobs within that batch group, which is running on the same priority inherited from the batch group. Now, at some time, you decided to change one batch job to run on different priority because of any business reason. You have an option to move that batch job out from the batch group and move to the corresponding batch group, which has that priority that you wanted to. However, if you want to keep in the same batch group, you can go and override that at the batch job level. So essentially with the PBS, we are setting the priority at the batch job level, batch group level, but we have a capability to override at the batch job level. Now, with the with PBS, it's kind of it aligns setting up a batch jobs priority based on the business processes and the need. So in the legacy or in the previous platform, what you used to do is that if you wanted to run something like high critical or like, you want to run something, a critical job, the business user was reaching out to admin, hey, create a new batch group, dedicate some servers for me to run this, like the month end process, right? So this kind of thing that you have to kind of go back to your admin and do all these prerequisites and do assign some batch server. Now with PBS, you can just use the highest priority that you have at the time of scheduling a batch job. So you don't need to go and talk to the admin and do the batch server and the group alignment. So that's kind of an, it's more of a business driven a batch execution and setting of the priority than earlier we used to do at the predefined batch server and the batch group. So when we turn on the PBS, so we have 5 different priority for the batch jobs. So we have low, normal, high, critical, and reserved. Reserve is the highest priority in the batch scheduling. Now, the way our polling logic works with priority-based batch scheduling is that it's going to pick up, batch tasks next to be executed based on the priority from the queue and execute it. So the benefit that we get is that at any point of time, right, if one server is not available right now, in the previous platform or the legacy platform of the batch, where if the one server is down because of any reason, any batch job that is assigned to that batch server will be blocked either in error state, or it will wait until the batch server is back online. With PBS, right, since it's not tightly coupled, it's going to pick up the available pool of batch servers and assign that batch to run based on the priority. And we talked about the near zero downtime. So with PBS having turned on, it allows us to do the near zero downtime servicing, because I can take a set of batch server for the patching, while the another set of batch servers are still available, serving the batch job that is supposed to run that time. Now, just look at the advantages that we talked about of having PBS and with PBS and before PBS. So you can see here that we are setting up batch groups, and then we are assigning those batch groups to the batch server. We can do one-to-many or one-to-one. So we can assign a batch group to a dedicated batch server, or we can have one batch group running on the multiple batch servers. So that's our previous setup. With priority-based batch scheduling, I don't need to I no longer need to do that configuration part. I will have the batch group and I'll set up the priority, and priority-based batch scheduling framework or engine will decide which batch server to use and to process any available batch job based on their priority. So there's no pre-configuration that we need to do the way we have been doing it in the past. Now, how does this priority-based batch scheduling works, right? So, so the way we have designed this priority-based batch scheduling, that you can see here in the pyramid, that we have 40% weightage. So this is not an absolute number. So this is not the number of threads being assigned to reserve capacity. It's not number of 30 threads going to be assigned to the critical, high, normal, and low. This is a weightage system that we have put in. So there will be always 40% weightage given to the reserve capacity, which is the highest in my priority, 30% weightage to the critical, which is the second highest, then 15% weightage to high, 10% weightage to normal, and 5% weightage to the low priority batch jobs. So the way the priority-based batch scheduling works is that when we have the PBS turned on, and I have the task waiting for me to be executed by PBS, the batch scheduler, there's a service that runs batch scheduler. What it will do is that it will pick up all the waiting tasks or ready to execute tasks from my batch job and batch job table. It will pick up those tasks, create 5 um, table in cache. So these are not actual physical table. These are the table in cache or in memory table that you can call it. So we create um, five different tables or cache table, where the scheduler will assign those batch jobs based on their priority to the 5 different tables, and then mark their weightage. So for critical, mark 40. Similarly for the critical for 30, reserved for 40, and the respective others. So that marking will be done by the scheduler. Then the poller that runs on each server will go and pick up the task from the corresponding queue based on their priority and execute it. So if I just give an example of, I have 100 tasks to be executed from each priority. So I have 500 tasks, 100 from low, 100 from normal, 100 for high, 100 from critical, and 100 from reserved capacity. So at any point of time, you will see the polar, the way it works is that, like we said, that it's not an absolute number. So it's not means like, if I have 10 batch server and 10 threads each, so total I have 100 threads. That does not mean that out of 100, 40 threads is going to be only servicing my reserve capacity. It works. So it's not an absolute number. So the point here is that it's a weightage system. So basically, if I go to the next slide, so you see this is the inner workings of PBS. So what a scheduler is doing is that it's based on looking at my batch job and batch tables, picking up the task that is ready to be executed, and putting into the 5 different tables, which we've marked as a different corresponding priority, and assign the weightage. The PBS poller, it is kind of service running on each batch server. So what it does is that it's going to poll. So basically, if you just go back and look at the way it works, is that it's kind of a rolling of the dice, right? So example, so the PBS from AOS 1 is going to poll the number of tasks. So what it's going to do is that it's going to run a dice of 100 faces, right? And based on the weightage where I have a reserve capacity is 40. So out of 100 phases, 40 phases is of reserve capacity. Then I have 30 phases is for critical. Then I have 15 phases is for my high. Then I have 10 phases for my normal and 5 phases from low. So at any point of time, if the polar is rolling the dice, the chances of getting reserve capacity is always high because I have 40 phases. So basically that number that we talked about, the weightage, it's increasing the probability of executing a bad job from the corresponding priority. So there is always high probability of executing the reserve capacity. And then critical, normal. So the way it works is that it's going to roll the dice. It's going to pick up, hey, I roll the dice and I got reserve capacity. It will go and pick up that pending task on the reserve capacity, if there is any. If there is no pending task on the reserve capacity, it will roll the dice again and pick up based on the next phase that is coming up. So there is one business advantage that you will see here. On the legacy framework or the previous batch framework, what was happening is that if you have 100 threads and you got a bad job, maybe it's low priority, and that bad job is running, it's going to occupy all 100, right? And unless that is finishes, you cannot have another bad job which is coming as a critical or is coming as a high. It's going to get those resources. With PBS, what you will see, and over the period, if you see it right, you will see that out of 100 tasks that I have or 100 threads that I have, few tasks based on the way this rolling happens, right? So you will see that when the critical and high are executing, there is still some resources assigned to the low priority batch job. So if you have 100, and if you just look at a brief period of time for maybe 20 minutes, 30 minutes, or an hour, and if you look at the batch history, you would see that your low also got executed, maybe 5 tasks only, and at the same time you have critical which got executed with 40 tasks because that's the weightage that we have set it up. Now, we talked about the reserve capacity, which is the highest in terms of our priority. So the one thing to note here, right, that weightage that we talked about, which is 40% for the reserve capacity, then we have 30 for the critical. This weightage system is not configured by user. This is managed by the platform itself. However, for the reserve capacity, when you turn on the PBS, we have given an option to go and override how much you want to reserve the capacity. So example, when you turn on the PBS and if you go to the system administration module setup, and there is a system parameter forms, which is all existing form that we have. And if you go to that form, there's a new tab appears, which is allowing you to do the reserve capacity. I can go for none. So if I go for none, so I'm not doing any reserve capacity. If I go for low, I'm going to do 10% of my resources for the reserve capacity. I can go medium, I can go high. So what we see on the parameter is low, high, medium, and none. This low, high, medium, none is kind of mapped with a percentage of the thread that I'm going to reserve for the reserve capacity. And this is not here, the numbers that you see, but it's been there in the doc. So you can go and refer to the doc where there you can kind of correlate the percentage. So what happens with the reserve capacity is that, say example, I have 10 batch server, 10 thread is the total 100 threads, right? And I said, okay, I want to do an high reserve capacity. So I want to reserve 25% of threads for my reserve capacity batch job. So what will happen is that the PBS scheduler will reserve 25 threads. So this is and the number of threads. The weighted system is not actually a threads. It's a kind of increasing the probability. Here, I'm reserving number of threads. So basically, if I set reserve capacity level to high, and if I have 100 threads, so it's going to reserve 25. So the way scheduler works is that the scheduler will go and look at the parameter, and if it finds that, hey, I have to reserve 25% for reserve capacity, it will go look at the very first AOS available from the pool and see that, okay, I need to reserve 25. How many you have the number of threads available? You see that I have 10 threads, it will reserve all 10. Then a scheduler goes to the next AOS from the pool and looks at it, how many threads. So I have 15 remaining. It will go and look at how many threads that I have. AOS 2 also have 10 threads, so it will reserve the remaining 10. Now I have 5 threads that I need to reserve from my reserve capacity. It will go to the third AOS And we look for, okay, how many threads that you have. And the third AOS will say that I have 10 threads. Okay, reserve 5 for the reserve capacity. So the total 25, like the full AOS 1, full AOS 2, and half of the reserve AOS 3 is reserved for the reserve capacity. So the reserve capacity does not go and reserve 5, 5 on 5 different server. It does like from first AOSs from the pool. The reason we do it to minimize, the time or the poller to go and poll and for each server and see how many you have reserve capacity. We want to reserve first few and give that to the reserve capacity because we want to treat reserve capacity batch priority the highest. So minimize any sort of polling or any sort of mechanism to go for me to go and find the right resources. So that's how the reserve capacity works. We can also go say no reserve capacity. Maybe there is a situation that you have in your organization that you don't need to have any reserve capacity. You want to have only critical, high, normal, and low. You don't want to have. Because if you go reserve capacity, then that percentage of resources is going to sit idle. It's not going to be utilized by anyone other than reserve capacity pool. But that's kind of framework that we have kind of provided. Now, the other things with the reserve capacity is that the way it works, right? So you have, let's example, you did a 25% reserve capacity, which means that you reserve 25 threads. That is being reserved for reserve. And now you got, let's say example, you got 40 threads that is needed for reserve capacity. So what it's going to do is that it's going to use first 25 from the reserve capacity pool, and then the remaining 15 is going to take up from the highest, right, even above the critical. So the way it works, right, because the way for the remaining one, the dice rolling will happen, and the 40% is for the reserve capacity. So it's going to use the remaining 75 threads that you have from there. So that's the way the reserve capacity works. So if I have more threads than I have reserved, it will pick up from the remaining pool. If I have less thread from than I reserve, for example, I have 25% reservation, but I have only 20 threads. So the 5 threads are going to sit idle. They're not going to be used. Now, prerequisites for PBS. So one of the prerequisites that we have for the PBS is to turn on the batch contention reduction feature, which I talked about, we introduced in PU 28 or 21. Now, what is happening right now with PU 47 or 1023? This is by default turned on for all customers. So this feature is already turned on. However, right, you still have way or capability to go back and disable it, right? And if you have disabled it, then you will have to turn it on for you to start using PBS. Because if you go try to turn on PBS, and if that feature is turned off, it will give you a warning. Batch enhanced form. So if you go, so right now in the current framework, we have a way to switch back between the legacy form and the enhanced batch form. Again, enhanced batch form has much more flexibility and an option compared to the legacy one, but you have an option to switch back between legacy and the enhanced one. When you turn on PBS, that um, that flexibility is gone. So you no longer have an ability to switch to legacy. You'll be only using the enhanced batch form. So that's a kind of the prerequisite or after effect of the having PBS. So when we turn on PBS, all the batch jobs that you have currently in your environment, it's going to be transferred to a normal batch priority. So that's the default that happens. So at any point of time, you turn on the PBS, within few seconds, right, it's going to be transferring all the batch jobs to the normal priority. And I don't know if you guys have noticed, but if you just go back and today and look at, there's a batch job. It's called system job to seed batch group association to batch job. So that's the batch job responsible for transferring my all the batch groups to the normal batch priority. So that's the change that happened when you turn on the PBS. And then I'll have a quick demo where we'll be kind of showing up the features and different permutation combination of PBS.
Thanks, Ajay. My name is Harsh Birla. I work with Microsoft Fast Track team as Senior R&D Solutions Architect. Let's take a quick demo of priority-based batch scheduling. So I'm into a sandbox where I have 4 AOSs. If you can see in server configuration, Each batch AOS, I have set up 10 maximum batch threads, right? So if you look at AOS 1, AOS 2 has 10 batch threads, similarly AOS 3 and 4. So overall, I have capacity to run 40 threads concurrently in this particular environment. From feature management, I have already enabled priority-based batch scheduling feature. So once this feature is enabled, you will see a different experience on batch group, right? So there is no more association of batch group and batch servers anymore once you enable priority-based batch scheduling feature from feature management. So if you look at batch groups, now all my existing batch group, for example, empty or batch, these have been assigned normal scheduling priority, right? So you can see these are my batch jobs. For example, I have alerts, email distribution, retail jobs, etc. All were using empty batch group, and now they have normal scheduling priority. So you can actually see all the batch jobs which are scheduled to run or ended from this screen. Uh, Similarly, what we have done is created new batch groups called critical and assigned scheduling priority as critical. Similarly, high batch group for our demo purpose as high, low, and normal, right? So you can see we have 4 batch groups. Now let me actually show you the setup for reserve capacity. So if you go to system admin and look at system parameters and look at batch global settings. So currently we have not defined any batch reserve capacity, right? It's no. So there is no dedicated capacity which is reserved right now. For this demo purposes, what we have done is created a custom batch jobs that introduces a kind of sleep pattern and then spin up a number of threads based on the parameter. And we can schedule different batch jobs and submit it in different batch groups. So for this demo, what I'm trying to do is, so let me quickly open up my Excel. So we have 4 AOSs, right, as we talked about. I'm going to submit this sample batch job that we have created. It's a custom, and then assign various batch groups like critical, high, normal, and low. We will spin up 50 batch threads. It will schedule them to run at the same time with recurrence 1. It's same workload. So what we are expecting, hey, the critical one should get finished and so on and so forth, right? It should finish in least amount of time because we are trying to leverage all the capacity, right? We can, a system can run 40 threads in parallel, right? But what we are saying, hey, let's schedule 4 batches that needs 200 batch threads to run, right? So let's quickly submit this batch job. Again, it's custom batch job, so I'm going to introduce 1 minute of delay, spin off number of threads as 50, and let's start with low. And let's go to recurrence, and we will make it run at 1250 in after 1.5 minute of time frame, right? So low is scheduled. Same 1 minute delay, 50 threads, and then normal. And we'll start this at the same time, 12:50 p.m. Then high. and one more for critical. And to start at the same time. So let's go to batch groups. So you see critical batch job is waiting right now. I will go inside it so we can see the execution for critical. Currently it is waiting. Hi. So if you notice, the time has started. So let me refresh this. So you see critical has already started. Around 26 batch threads are being executed. Similarly, for high, system has started picked up executing some of the batch tasks. Let me go to normal. It's also executing because the time is same for all of them. So you see number of batch tasks, it has created 50, but out of 50, it is executing 4. And let's go to low. It's also started, but because the priority is low, all the tasks are in ready state, but only 3 are executing, right? So the highest priority and resources are being provided to critical, right? You see 26 are being executed. Yeah. So let's give it a minute for it to complete, right? And if you notice for the critical, it has already completed some of the tasks, half of the task, and it's currently working on the remaining half, right? So what we are expecting, the critical one should get the highest priority when you actually submit the same workload, same batch jobs to start at the same time, right? Let's take a quick look at hi. Still executing some of them. So I'll take a pause and then, we'll take a look at execution. Okay, so our batch jobs are executed now. So if you see the critical batch job actually start time, date and time, and then end date time. So it took around 3 minutes, 17 seconds. Similarly, and let me close it so you can actually see from the batch group screen directly. So critical, it was executed and it completed, right? The critical one, if I refresh the screen, you can actually go to job ID and look at the job history screen to get actual date and time, right? So this is critical. Similarly, this is the experience for high. It took 4 minutes, 19 seconds. For normal and for the low, right? So the low priority batch job took the longest time, right? Which is what we expected. So if I go to my Excel and analyze, this took the least time because it's obviously critical priority, and low took the highest time, which is what we expect, right? Uh, now, if you look at in system parameters, we don't have any reserve capacity. But once we assign reserve capacity in system parameters, so if I assign some high reserve capacity, that means 25% of my capacity will be reserved to execute some of the dedicated batch, right? What we need to do is basically assign and create a new batch group. So currently we have critical, high, low, normal. And if we are looking at reserved capacity, then we need to use reserve capacity as a scheduling priority, right? So currently what I've done is in the system, we have a high reserve capacity. That means what we are saying, hey, reserve 25% of my capacity. That means 10 threads. So one AOS will not execute, only we will have capacity to run 30 for critical, high, normal, and low. And for reserve group, we will leverage uh, reserve batch group, right, to run. So if now I schedule, again, do the similar exercise, right, to run the batch groups, right? So right now, since we have only 30 threads available uh, for batch jobs, right, except reserve capacity. So 75% is my capacity which is available. That means 30 threads. So even critical will take longer because I have less capacity, right, from a batch group perspective. So I will go ahead and schedule some batch jobs and then show you the results of of using batch batch group with reserve capacity. So what I'm going to do is again use the same. So let's do critical batch, and we will schedule it to run at after 2 minutes. Okay, so that I have enough time to actually schedule it. So I'll take a pause, I'll submit these batch jobs, and then we will analyze the results. Okay, let's take a look at the various batch jobs. Now we had some of the reserve capacity. So I was a bit late to submit the reserve batch job. So if you look at it, it started at 4:50 p.m. and finished uh, within 4 minutes, right? However, the critical batch job started at prior to reserve capacity. So if you look at it, finished because it got all the resources, all the required capacity at that point in time. However, if you look at the high, it finished right now, and it took longer because now the reserve capacity batch job got the highest priority, right, that point in time. If you look at the normal one, it took longer, right, almost same time, and then the low one, I believe it's still executing, right? So that's how you can actually see, experience, how the PBS scheduler is using various algorithm to honor these priorities for batch jobs. We also talked about, changing the priority on the batch job. So if you go to batch job and you want to actually look at the job ID, yeah, so you can actually edit it. Currently, it's assigned batch group as reserved, and it has reserve capacity batch scheduling. However, if you want to override it, you can actually override and say, hey, I want to execute this batch job on a different priority, even though my batch group is different, right? So you can actually uh, override the priority here on the batch job level and save it. So once you change the status, let's say to waiting, right, for this particular batch job, it will pick up the high capacity for the next execution. Yeah, so
Thanks, Harsh. Now I'll hand it over to Akshat for the best practices about the priority-based batch scheduling and call to action. Akshat.
Thank you, Ajay. Thank you, Harsh. Now, in the next slide, let's talk about some of the best practices we should follow when we enable priority-based batch scheduling feature. So first one is please do not assign same priority to all batch jobs, like putting everything to high or putting everything to critical, because then you are not utilizing the algorithm or the problem statement which we are trying to solve here with this new framework. Next best practice is do not schedule same priority jobs to run at same time, like putting all normal batch jobs in the morning, high priority batch jobs in the afternoon. So it's the second point is tightly coupled with the first point. If we are doing this, then the actual problem statement where we started to build this framework was to allow the framework to run different priority jobs with their weightage at the same time. So if we are not following that, then we are underutilizing the power of this framework. Now, next best practice is reserved queue. So as mentioned earlier, so reserved queue is there to dedicate a specific number of threads to run the highest critical batch jobs. So if you have any batch jobs which are very critical, then utilize the reserved queue. That will work as a dedicated resource for the batch job. Like today, we only have the option of creating a batch group and then assigning the servers so that my most critical jobs will run on those servers. But now with the reserved capacity, you can actually reserve some of the threads to run your most critical batch jobs. Now, next point is it is recommended to use the same number of threads across all your batch servers to eliminate any kind of performance issues. Another point is, as Ajay has also mentioned previously, that priorities are not used to stack rank tasks. So it's not tied up. So 40%, 25%, this is not tied up to the number of batch tasks, but this is weightage or probability, you can say. So a simple example could be if at any moment of time I have 10 threads available and there are 10 tasks mixed across reserved, high, normal, low priority, then the chances of reserved priority is 40% being picked up by those number of available threads we have. So it's definitely not number of threads are not aligned to the weightage. Now, again, next best practices. Each of your batch tasks should implement batch retrieval interface to avoid any intermittent issues, the major one being SQL transient errors. Now, most of our system batch jobs has already this in place. So this is more about if you have any custom jobs or custom tasks, then yeah, it is always recommended to implement this interface so that you can avoid these SQL transient error. So now moving ahead, I will quickly hand it over to Mata to talk about timelines.
Hey, thanks, Akshay. From timeline perspective, I would like to call out three important times here. This feature was announced GA on April 1st as part of the 10.4.25, and we have started seeing many customers have adopting this feature. And other two timelines which I would like to call out, like this feature will be enabled by default for all the new instances getting created in the FNO, and that is going to be effective from 10.4.28, that is starting July. And one more the critical timeline which I would like to call out, like this feature will be enabled by default for all the existing instances starting 10.0.29. So we do have started seeing that more adoption for this feature, and we recommend to enable in the sandbox and then enable in this prod. And as Ajay mentioned in the previously, right, this is a prerequisite because in the roadmap we also have the near zero downtime servicing, like whatever the framework we have built. We are going to do the in-place patching for OS updates as well as with the quality updates as well. So that's why I would say like we recommend to have this feature as a prerequisite so that way you can get the benefit of all the different types of services what we have in our roadmap. Over to you, Ajay.
Thank you, Martha. Okay, so now call to action. So first of all, we need to identify the priority of currently running batch jobs. Second, once the feature is available, it's already GA, so available. So you can turn on this feature. So once you turn on this feature, it will put all the existing batch jobs to normal priority with no reserved capacity. Then, as part of your first step, which was to identify the priority, the third step is you can go ahead and update the priorities of your batch jobs or batch groups based on what you have identified as part one. And then last one is apply the reserved capacity. So if you have highly critical jobs which needs to be run, then use the reserve capacity feature to dedicate a specific number of threads for those critical jobs. Now, so the main call to action is work with your project teams to adopt this PBS because this is the future. It is definitely required for near zero downtime servicing experience. And as soon as you keep using this feature, we welcome your issues and feedbacks. You can reach us via the dedicated Yammer group or through Microsoft support or any communities. So yeah, now this is it from the presentation. So I'm handing it back to Otto. Over to you.
Excellent, thank you. All righty, well, I'm going to go ahead and post a link here to a survey. It's a little short survey there in the Q&A panel. We certainly appreciate the feedback on today's session, what you may like to see in future events. Certainly appreciate your participation there, and hope the content today was useful. And as a reminder, the recording for today's session will be available over on the TechTalks Community Dynamics page within about 5 business days. So it looks like there may be another few remaining questions. I know we do have a couple of minutes of extra time here. And looks like we're tackling some of these via text there. Ajay, do we want to address any before we wrap up today?
Yeah, I think there are a few questions that we can take. One of the questions currently is, will it be a mandatory feature in the future?
Yes, so as Martha just spoke about, right? So from 29 onwards, so we are going to enable for all customers, right? However, the making it mandatory on the kind of, we will follow our guidelines that we have for the feature deprecation. But yes, that's in the roadmap. Yeah.
Right. There is another question, Ajay. When a server goes down for maintenance, does it finish all its pending threads before it goes down, or it still pauses those?
Yeah, so it's not going to pause. So whenever a server goes off from the pool, so we make an entry for all the tasks that we're running. And if those tasks were marked as an idempotent, and when the server is back or when there's an available threads, so those idempotent tasks will be kind of, getting, I would say, restarted. And then there is a retry flag on the batch task will be marked with, the number of retry that we made. So example, start with a 0. If I did once, then I'll mark it once. And I can do until only 5. So until 5, if I don't restart because of any other circumstances, then the batch will error. But technically, if the one server goes off, the batch will go back and to we maintain a pool, and from there we'll just kind of restart the batch job using our retry framework that we have, which is not the the retriable framework. It's an idempotent that we configure for the batch jobs.
Yeah, makes sense. There's one more question. What will be the priority of batch jobs which are not assigned to any batch group?
So, like I said, so if the batch job is not assigned to any batch group, which means that it's going to go to the normal, right? Empty batch group, right? So so anytime you turn on the PBS, all existing batch group are going to assign to the normal priority, including our empty batch groups. So if you're not defining a batch groups for a batch job, it's going to go to you go and use empty batch group. And if empty is assigned to the default normal, then it's going to run in the normal. However, if you want to have empty as a different priority, you have an option to go and change the priority for even empty batch group.
Right. Yeah. Yeah. Therefore, I think it's good to analyze, hey, which batch jobs are running against the empty batch group, because each batch job runs against of any batch group, right? It could be empty batch group that comes by default, right?
Yeah. So there are a few scenarios just to mention out here, right? Is that like MRP, your inventory closing, where you define the helper threads, right? So normally all the batch job that we have designed, it's going to use the threads from the parent. So example, if I run an MRP with the 10 helper threads, it's going to use the batch group that I use for the MRP main thread, right? It's going to use the same batch group, and then it's going to follow the same priority. However, right, there is a scenario the process automation framework that we introduced, right? It uses empty batch group. So you need to work on your empty batch group, how you want to set the priority. Or if you are submitting a batch job from the code, right, using X++ logic and not giving an option to user to define a batch group, then in that case, normally we go and use the empty batch group. If you're doing that, and if your business needs to have a different priority for empty batch group, definitely go and change the priority of empty batch group.
Yep. Yep. One more question, Ajay, I see is, how's the batch priority weighted against critical job?
So the batch priority against the critical job. So I think the weightage that we have defined, right, it's a 40% for my reserve capacity, right, and then 30% for my critical. So at any point of time, there will be 30% chances to pick up from the critical, even though whether I'm using reserve or not. So if I have a reserve capacity set up, right, I'm reserving the reserve thread. But if I don't have reserve capacity set up, I have all 100 threads available, but the 30% is going to be getting to the critical one compared to the other. So we have seen that in example, right? When I had all 4 running at the same time, and if you just look at the end of the day, the number of tasks executed and the priority given to the critical was highest compared to the others, though all were running at the same time.
Yep, thanks, Ajay. And the last question I see, what would be your recommendation and guidance in defining what is the definition of a critical batch job so that we can explain this to business users?
Yeah, so, if I'm a business user, everything is critical for me, right? Because I want everything to be finished on highest priority compared to the others, right? That's kind of a normally it happens, right? That if I'm given an option that what priority I wanted to use, I'll use critical for everything. However, the guidance, like we don't have any specific, but just looking at the business priority and the customer that we have worked with. So example, my retail statement posting. So for some customers, they need to post the retail statement by 12 in the midnight because they need to do a fresh ordering in the early morning. If that does not happen, they won't be able to put the order in the morning. For those kind of jobs, definitely setting the critical is mandatory because that needs to be done before a certain point of time. And any resource that I have and whatever the resource that I have, I want to assign to those bad jobs. So that's the kind of a guidance, like, processing payment, doing, any sort of, this kind of critical, like processing payment, my retail statement, my any integration job that I want to be finished because there's a trigger mechanism that I need to put in something else after that bad job. So those kind of bad jobs, I would say that following critical would be the recommended. In fact, we do have some customers that are using all normal, but that's not a guidance, right? Then we're killing the purpose. But yeah, I think the critical is mostly I would recommend for the time sensitive batch job that you wanted to have, right? Because there is a downstream process that you need to kick in after that. For those kind of jobs, we suggest to have critical or high. Reportings like reports and all, again it's guidance to the user that hey, you are running report, why it needs to be critical or high, right? Normally use normal. I won't even go to the low. If I go to the low, like in my year-end reportings, right, like any sort of reporting that I'm doing is going to take, let's example, the vendor customer aging and all that, which is going to take time and it's going to take time. It's not a mandatory for me to have the report ready today. I can submit in the low, I can come tomorrow and download the PDF. So those kind of jobs go to low, but normally I have seen that the people use reportings and all as a normal, not low. Low is very rarely used that I have seen. Yeah, that's kind of an example from the working with the different customers. Again, there is no hard and fast rule which one is critical, but that should be the guidance. Which one's supposed to be critical, which one's supposed to be the jerk capacity, which one's supposed to be the high.
Yeah. Thanks, Ajay. And one last question. Is it possible to have one single batch job run normal in the morning, high in the evening, and critical at the night time?
Technically, yes, right? You can play with either batch group by moving that batch job, or you can override it, right? But there is no, there's nothing in the scheduling mechanism that I put a priority based on, the timing. Priority is predefined on the batch group level, can be overridden on the server level. So technically possible, but you will have to do a manually override of the priority. Yeah, Arts.
Yeah, thanks, Ajay. I think this is what we had from a Q&A perspective. If there is no more questions, we should be able to close.
All right, great. Thanks again, guys. And of course, thanks our audience for joining us today. Again, we certainly hope the content has proven useful. And as a reminder, the recording for today's session will be available over on the Tech Talks community page, Dynamics page, within about 5 business days. Hope everyone has a great day. Take care.